I've been working with this data space where we use DBT for transformations. So I thought, why not I could share my knowledge based on my working experience with DBT. Okay. Before I start, I just wanted to know from you all, like how many of you are already aware of data pipelines or familiar or worked with data pipelines earlier? Okay, fine. Then I'll just give an overview of how a data pipeline would basically look like, and then I'll go into the actual tool. Okay. Okay, I'll start off with the agenda. So to start with, I'll mostly just give an overview of how a ELT data pipeline would look like. And then we would get into DBT and its features, how it's different from other tools. And then there are two components provided by DBT. One is core and cloud. I'll give an overview of that. And then the core components which makes up the DBT along with its adapters and other configuration files. And then some concepts of DBT. There are a lot of other concepts. I'll just cover some of them, which are quite important and to know. So in that, it will come as Jinga and macros. And then apart from that, it has incremental models, strategies, and then other types of models. We'll cover that, and then I'll give a short demo of whatever is possible. Okay. Okay. So to just see what is a data pipeline. So data pipeline is basically a sequential of digital processes. The purpose of data pipeline would be to either to get the data from some set of sources and then load it to a data warehouse or database based on the type of the data and what is the purpose of the data. And then you transform it into a way where some actionable insights could be derived out of that data based on the business requirements. So this is why we have a data pipeline. The usual process that is predominantly followed is we have like ELT or ETL, where E stands for extraction, L stands for loading, and T stands for transformation. So the first process will be extraction. So you could have one source or multiple sources based on from where your data is fetched. So you first extract fetch the data from that sources. It could be from an API response. It could be a set of files or files that are uploaded in the server. It could be any sort of source from where you're getting that data. And then the next, the load step. So load step is somewhere you load the data, you get it to a data warehouse, and then only you will be able to transform them. So get it to that source. So here I'm taking an example of in GCP. So we have something called cloud storage, Google Cloud Storage or buckets. So where we will be able to get the data in majorly like a raw format or like in a semi-structure or raw format. It could be anything. And then you get it into the, and then lastly you have the transformation step. So this transformation step is one major step that is required to transform the data, enrich the data, and get it to a usable format. So different transformation processes that are commonly followed is one is data cleaning, where you remove the duplicates, correct the errors, handle the missing values. If that's the data that is what is that is prepared manually, right? There could be a lot of errors in that, so we'll have to correct and handle them at initially itself before even you use it for transformation. And another transformation would be like data conversion. So from this source, you would get it into some types, and then you would convert them into specific data types that is required, and also specific structures. And then that comes the aggregation. So in instances where you have multiple sources, that for example, you have like a company has product team, customer team, order team. So you would get a lot of, each team would provide you some data. So individually you can't, you need to collate all this data to get it into some report or anything. So in that case, you will have to combine this data in a format that business could be used. And data enrichment. Now, for example, when you get files as one of your source, you would get a lot of files, and on a day-to-day basis, you would be processing those files. So when you process, you would most probably get that data into the BigQuery in the form of rows and columns or in the form of records. So when you have so many records, you would need to add some metadata like this record belongs to which file name, which row number it belongs to, how many records that a file had. So all these data would be required to add as metadata. So this comes under enrichment, and there is another thing, data mapping and structuring, where you reorganize the fields and everything. So these are some basic transformations that are usually done. Right. So this is like and also there are two types of pipelines, we could say, based on the way the data is fetched. That is, the frequency of the data is fetched. One is batch pipelines, and another is streaming pipelines. Batch pipelines in something you fetch the data in a periodic time, periodic intervals, like once a day or hourly ones, and then you get that data. Once the data is available, you transform and make it available for the downstream systems. Other is a streaming pipelines, where you get the data real time, like sensor data, the feeds data, and all of that. So the way of processing is completely different when compared to streaming pipelines. So now, in this session, we would mostly be focusing on batch pipelines, because DBT does its good work only in batch pipelines. Its features are mostly aligned with data that could be processed from a batch pipeline rather than a streaming pipeline. Okay. Right, and then yeah, so this DBT, where this tool comes into picture, is only in the transformation. That is, once your data is available in your data warehouse or database, then only you will be able to use that DBT tool to do the transformations. Okay. Okay, so okay, now we'll just understand what is DBT now. DBT's full form is Data Build Tool. It's an open source software tool, and it is majorly used to do only SQL-based transformations. And then, as I said, in the entire ETL process, it focuses only on the transformation part and not the extraction and load part. So you will have to most probably use some other tools or pipelines to get the data first available in the BigQuery or in GCP, and then make the transformation. So, and this tool is cloud agnostic, which means it integrates very easily with other cloud platforms like Redshift, Snowflake, and then Postgres, and many more databases. So it's very easy. So now, for example, if you are having a system where you're using database in AWS, and you have implemented all your transformations in DBT, and now you're migrating it to a different database, it's very simple. So that the code doesn't require much changes, just few adapter changes, and everything is need to change, which you will be able to, and then you will be able to get your data into your other database. So it integrates seamlessly with other database, and then it has built-in testing. So this test, it basically helps to ensure the quality and the integrity of the data. So in testing, so there are some type of tests. I'll cover them, but it has a test which you could implement using the YAML configurations. And as I said, right, so the DBT mostly focuses on SQL-based transformations, but in your conventional SQLs, you won't be able to use variables, or you can't have any dynamic variables there, right? So in DBT, you could combine with a templating language called Jinga, which allows DBT to get the dynamism into the SQL queries. So I'll also explain about that in upcoming slides. And then it has a feature called auto documentation. So if you have a lot of transformation logic, different tables or different models, right? So it will say, like, it documents like what are the columns that as if you specify them in that YAML configurations, it would generate that documentation where it says, okay, how many columns it has, and what does a field mean, all of that. And then it is modular. So DBT has something called macros, which helps you to, like, in your actual application code, you write functions, right? So that you could reuse them across all the other SQLs. Likewise, in DBT, there is something called macros. Once if you define it, you could, wherever that logic is required, you could reuse them. So this avoids the code retention. This is a good thing. And then yeah, so it's easy to schedule and version control, everything is there. So this is like overview of the features of DBT. Okay. So DBT provides two components. One is DBT core and another is DBT cloud. Okay. So DBT core is something in open source version. It's a CLI, it's a command line interface tool. So this allows you to have all your SQL based transformations. It allows you to write your test. It will allow you to document. All of that is available. Only thing is, you will have to set your own infrastructure. Like, for example, if you want to version control, right, you will have to integrate with GitHub or Bitbucket so that you could keep track of the changes that you're making to the transformation logics. And then if you want to schedule them that run on a particular schedule, you will have to integrate with some other orchestration tool like Airflow, so that you will be able to schedule them and then monitor those jobs. But when it comes to DBT Cloud, right? So DBT Cloud, it's a fully managed, it's a cloud service that's provided by DBT itself. So that provides you a web-based interface where it's a hosted solution. So there, it gives all the features of DBT core, but only thing is you don't need any other, you don't need the external tools. It has inbuilt versioning, it has inbuilt what is that, inbuilt scheduling, logging, all that. It's available inbuilt in that DBT cloud itself. Just that that is a pricing version and this is a free version. So DBT core, like mostly it's used by data engineers, analysts who prefers interacting with command line itself using the commands. So they have more control over the code. Okay. Okay. We are going to get started with the main components of DBT. So until then, do we have any questions or anything before what on the overview of DBT itself? Okay, thanks. Okay, this DBT core components are what makes DBT. Like how do you develop your sequels? That is the core components now. So you have something called models. Okay, models are nothing but your sequels files. Okay, .sql files. You write all those select queries. You do your join, CTs, whatever transformations are required. You put them into your SQL files, and that gets materialized into a table or a view or whatever materialization is required. So what materialization means is how you want that data to get persisted in your data warehouse. That you will have to specify to DBT. Do you want it to create as a table? Do you want it as a view? Or there are other models, other materializations that are given by DBT, like incremental and others. So that is called materialization. So you will have to mention them as well in the models. And when it comes to test, so DBT allows you to write test as well, like how in your application code you write unit testing and all of that test, right? Likewise, we have something called data test, which ensures your data quality and integrity. So there are two types of tests that is available in DBT. One is generic data test and another is DBT unit testing. These both are quite important or for a good data pipeline, but the purpose that these two are there is quite different. Okay, so this generic data test is right. So it is to test the integrity and correctness of your data at the high level. Or validate the source. Now, for example, some examples of generic data test that is given by DBT itself is not null check, or checking if a column is unique, if the values that are coming in that field is unique, and then accepted values, like for a field is supposed to have some set of values only, then you could write that as test. So while it runs in production, at any point, if the source changes, because we don't have control over the source, we might not have. So if the source changes and if the values which comes are different, then that test would alert us that the test would fail, and then we would know, okay, so this field is now getting some other values. Then that is something we'll have to go and check your data, source data, then why it is different, and then take actions. Or else it's also used in development itself to catch the early issues while you develop itself. Now, for example, you mentioned that in a particular model, for a particular table, that field is supposed to have only unique fields. So you are mentioning that test as unique. Now, for example, you're doing some complex transformations, you're doing multiple join with multiple tables, and it ends ends up in the data where that unique ID is that it is not unique. It is getting duplicate records are coming. So in that case, when you run your entire test, right, then you will be able to know it in your development itself that your logic is somewhere is wrong and you have to correct them. So this is the purpose for the data test. Another type of test is unit testing. Unit testing is something which similar to the unit test that you write for the application code also, where you have a specific logic and then you check, you mark the inputs, you mark the outputs and check, right? So whether if that is the input that goes to that functionality, is that the output that you get? So you could write such kind of test also in DBT to check your code wise. This is code wise, the logic wise, is it correct or not? And and then the another important core component that is given by DBT is snapshots. This is one powerful thing that is provided by DBT. So this is to capture now, for example, if every day your data keeps on gets refreshed, so it allows you to track the historical changes. Now, yesterday, if the data was having for a particular person, the email was joe@email.com, and the next day he has changed it to some other email ID. But you want to know, you want to keep track of what it was earlier, that email, and what is the new email that he has updated. In that case, you would use snapshots. So snapshot model is something that you could track your changes over time. So it creates historical records of your data, capturing the snapshot at a given point of time. We'll talk more about snapshots in the upcoming slides. And seeds, this is nothing but some static files. So in data, you would have, right, like you would have a currency code, and what is the, if there is a market, what is the currency that they're using, the code. So that is not going to change or frequently. So you could have them something like a lookup tables or some static files that you would have in your DBT. You could load them using the DBT itself into your data warehouse. So such type of static files are called as seeds. Okay, since I've covered like these many things, right, we'll have a short demo. I'll just show you how this models and how does it look like, so that it will be understandable in the upcoming thing. Okay. Right. So this is how your basic DBT project will look like. Once you initiate a DBT project, right? So it will give you some folders for macros, some folders for models to define your model, some folders to define your seeds, some model for defining your snapshots and your test. Now I'll just show you what are models now. So I have some models written here. I already have my raw data in my BigQuery. How do you do that for PyCharm? Mm-hmm. Yeah. This one now. Okay, this looks huge. How do I traverse to the models like in the project structure? Or appearance like that. One second. I'll do this. Is it now visible? Like, is it? Okay. Okay, so I have some models here. So if you check in my refine layer, I have like some data about customers, orders, and product. So in product, I have this product details.sql. Okay, so this is called a model. You will define define a select queries here, and that gets materialized as tables. In the usual SQL queries, you write create or replace table, all of that. So, but that gets internally created by DBT itself. It's enough if you just specify your actual logic that you need in your data set. Okay, so I have my DBT sequels here. So this is called a model. All these are called as models. Whatever that we define under models directory are called models, and which are the SQL scripts. Okay, so yeah, so we have something called config here. So this is this is where you mention your materialization. If you want it as a view, you can mention it as a view, or else if you want it to as a table, you could mention it as table. And there are other materializations that we'll talk about. Okay, so here I've got data from a source, and then I have some filtering and all of this. So if I execute this, I will get my data set created in the BigQuery. I have integrated with BigQuery in GCP. So this is this source, right? So this source, what it means is you could define your sources here, sources.yaml. So you will have what from wherever you're getting that source. So I have my sources from a specific project and data set. I'll talk about this quite later. What does it mean? But this is, I have set this project and data set to my earlier projects and data sets. So this source gets used in my SQL here. Now, if I run my, 1 second, this is changing now, right? Okay. So this command is used. So dbt run command is used to execute your models. I'll show you how these models get translated into queries that is understandable by BigQuery. Okay, so this has now created the table for me in my data set. So you have something called target folder. So whenever you run your dbt commands, this target folder will translate into the query. Internally, what query is getting generated. So in my run for product details, if you check, I gave only this select statement, but it translated into these queries, so that the BigQuery will be able to understand and then create the data set there. So this is how it would look like. So so there are other configurations, like you could mention, do you want your table to be partitionized? Do you want your table to be clusterized? So you have options like here, you could mention them here in your config, partition by, which field you want to partition, what is the data type that you want to partition. And then you could also use cluster by. Cluster by is used to group a set of, you could use a set of columns or either one column, anything. So if these configurations are mentioned here, DBT would internally translate it into queries that is understandable by BigQuery. So this is how models look like. Likewise, I have other models as well. Um, so here again, so it's getting us some source from another table here. I have again defined my sources here in my sources, so that it would be able to generate that data set. So this project and data set is coming from another YAML file. So where I have mentioned which product it has to take and which data set it has to take. So you'll get the information from this configuration file, which you would be able to see it in the query. So this is how it is getting that project and data set value and then creating the table in the BigQuery. Right, so this is regarding models. Now I was talking about test, right? 1 second, before that, let me do this as well. I'll also, this is again similar model I had, just a short model where I have another thing, like where it has to check only if this phone number follows this reject, so it has to come. Okay, so this is fine. So now we have some models here. So we our data is now available. Now now we'll have the test. So I mentioned, right, so we have two types of test. One is generic data test and one is the unit testing. So the generic data test, you have something called schema.yaml configuration, where you could either document your models, document as in, now I have just mentioned what is that name and what that table is for, and then I've just mentioned one column. But here you could mention all the columns and then give that what each field means, what kind of values it is supposed to have. In then finally, I will just have a command that would where the document would get generated. There you all those details would be reflected. So in that case, if anyone new person is coming and then seeing your data model set, they will be able to understand what each table is having, or else it'll be very easy. They can't go and ask each and every person to know what this data belongs to, because only the person who developed it might have the maximum context. So you could give all those details so that it is usable. Okay, so here I have this test on my product details table. So this product details is nothing but my model name. So this and yeah, this DBT will consider your file name as the table name in your BigQuery. So whatever your name that you give in your file is what will come as table name there. Okay, so here on the product ID, I have mentioned my DBT data test that that this field should be unique, and this field should is non-nullable. Likewise, I have similar data, product invalid raw, but there are some what is that? It has some discrepancies there, so that we'll be able to see how the test fails. And there is another configuration called store failure as, which means when the test fails, it stores that data into a table in DBT. Now, if you're using DBT Cloud, there'll be integrated monitoring and logging and all. Now, if in your DBT core, that is not available. So so for alerting, what you'll have to do is you'll have to do something like this, where you fetch that test and then check and then do the alerting, so that you get to know when the test fails. Okay, so and then I have another test on my order shipment status, which is in this model. So it has a field called order status, which says what the shipment status it is. So I have mentioned some values that this field is supposed to have only these set of values. Okay. So these are called data test. On a high level, you're having your test on your data level, so that whenever there's a change in source or anything, you will be able to know. And then there is another thing called unit test. So unit test, for that you will have to write a separate YAML file called unit test. So it would be like this. So you could mention your test name, like how you do in your application code, right? It will be in understandable format. You will be able to, by the name itself, you will be able to know what you're going to assert on, right? So I have a test name called when no city is given, city should be other. So this, I have written a test on the customer details. So if you check, I have a simple logic here where I say if the city which I get from the source is null, then it has to replace it as other. So I'm not giving any null values, I'm handling them. So if there's any null, I'm giving it as other. Okay, so this is small logic. When you build complex transformation models, the unit testing will be even more useful. Okay, so here I'm mocking the inputs now. What is the input I am giving? So here I'm using only one source, that is this. Likewise, if you're doing multiple sources, you will have to mock the inputs for all these sources, like how you do in your usual application code. Okay, so here I'm mocking my inputs. So these are the columns that I get from that source. So I'm giving all these columns, phone number, and then I'm giving one city as Mumbai and other one as null. So the expected output is, you give your what are the rows that you expect is for Mumbai it should be as it is Mumbai, and when it is null it should be other. That is your expected. So all these have, so this is how you write your unit test and the data test. And the command to run your test would be this one, dbt test. So now it will run all the tests, both generic and the unit test, and then it will show us the. Okay. So what it is, right. Okay. Mm. So, so this has started and then failed. Okay. So here what it says is two records are not null on the product invalid row. So this is the data set. This is my not null check on my product ID field. It has failed. And then there is, oh, I forgot to mention another test. Um, okay, let me explain that also now. So apart from a generic test, which is given inbuilt by DBT, you could also define your own test. That is what you do it in your test folder. So I have my stock quantity test here. So what I do is I am doing this test on my product invalid row model, where in that data set I have the, for every product, what is the stock available is present in the data set. So obviously a stock can't a number of stocks available can't be negative, right? So for some instance, if it comes as negative, I'm doing a test on that. So test is something, if you give, like, what is that failure scenario, how you get that records is the logic that you give here. If this returns any records, which means the test has failed. So this is how your custom test, you could write based on your model, your business logic, you could write your own test. Okay, so in my data, the raw data I have one record where that stock quantity is negative. So it is giving me the failure where my stock quantity test has failed. Maybe I could show you the data sets now so that it will be easy to. Okay, product invalid row, right? Mm. Okay, so if you check here, I have two records where my product ID is null. So I had a test, generic data test there, that this field is not supposed to be null. That is why that test has failed, where it has showed it had two records where the product ID is null. And then I had one record where my stock quantity was in negative, -120. So for that, I written a custom test that this data stock quantity usually is not supposed to come negative. For some reason, if the source is giving that data, then we'll have to report to them that this data is wrong, or it's not as expected, or if there is any change in the way this data is being sent. Yeah, and then there is another test on the order shipment status. I'll show them again in the ID. So here in the accepted values, I had only shipped, delivered, and then a few other values. So here we are getting two records where we're getting processing as the order status, which is not an accepted value. So that is why that test failed. It reported me that apart from accepted values, there are some other values that are coming in the data set. So these are the tests that you could write in your DBT now to basically check your data, how the correctness of the data, basically. Right. So I'll switch back to my page. Mm. Right. Ordinal stock quantity I have showed. So here it has said why failed in test accepted values. So this test, it has failed. It has been one record which has been failed. And also, as you mentioned, so here in the stock quantity test, I have given my configuration as store failures as a view. So whatever the failures that has come, right, it has been stored in this view now. It is created internally by DBT itself. It is created in my BigQuery, where I could go and check what rows have got failed. So this is about a DBT test. Mm. And then I think about snapshots and incremental models, we'll cover them. Okay. Yeah. Yeah. Okay. So until this now, like I have shown some demo and everything. So do we have any questions now before we proceed? Is it so clear? Okay, fine. Good. Okay, now, so you've seen how these models look like and all of that, right? So as I have just mentioned, I've just given my select or SQL queries there. And what you see is in the target folder, the way these queries are getting translated into a way that BigQuery is able to understand. So how is that DBT is able to do that? So there should be something, right? Like it should know first that database is BigQuery, how it's able to do that. There should be something, right? So that is where this adapters comes in. So DBT adapters. So this DBT, basically it connects with any of your database warehouse or data lake. And these SQL speaking platforms are called as data platforms. And DBT connects with various data platforms, like I said earlier, Redshift, Snowflake, BigQuery, provided by any cloud providers. So so this adapters is something that tells the DBT to how do you like, because now, for example, in that partitioning, right? With respect to BigQuery, it is called as partitioning, but with respect to Postgres, I think it is called as indexing. So it is different, but your logic would be same. What the configuration you would give is same. But based on the database, it has to translate that query in the way that database understands, right? So for that is why we have the adapter. So this adapter plugin is internally, they have only the Python packages. So for BigQuery, we have DBT BigQuery. For Redshift, we have DBT under hyphen Redshift. Likewise, for each and every data platform, DBT provides us a adapter. So installation, that's it. So if once you install that, DBT core will be able to identify, okay, this DBT BigQuery is installed. So then it will have to translate the queries based on the BigQuery's language, as in how BigQuery will be able to understand. So this is about adapters. So I had already installed my DBT BigQuery in my system, so that's why it was able to understand. And another thing, connection profiles. So now we have defined the models. We have mentioned how it will have to translate the queries. Now, how does it connect to the database? How does it connect to the data warehouse? It requires that details also, right? Only then it will be able to connect to that data warehouse. So for that, we have something called profiles.yaml in DBT. Um, so this is it visible? It's visible, right? Yeah. So there are multiple ways where you could define your profiles.yaml. I have mentioned two ways, where via gcloud and then via service account. Usually when you communicate with GCP, right, for every application there'll be a service account that gets created. So if for that, what you will have to do is you will have a profile name, that here my BigQuery DB is the profile name, and then you give your target or the environment. Like in the outputs, you could mention how many ever environments. Like you could have a connection profile for dev, for prod, for QA, based on the environments. So that when you run your DBT models based on the environments, you could even configure the variables there. Okay, because for prod environment, it will be different, right? The credentials will be different and everything. So in my OAuth, I would just give which database I'm going to connect with, that is BigQuery, which type of method, OAuth method, and then which is the project ID where this DBT should create the data sets, and then my data set name. And threads is nothing but how many models it could run parallelly, the concurrency basically. And then there are some other configs. These are some must-have configs that we'll have to give in the profiles.yaml. Likewise for service account, it's also. So this profiles.yaml, you will have to create it in a specific in your root folder inside that .dbt. In that way, DBT will be able to find them. So what happens is when you execute a DBT, so I showed you when I executed a DBT run command, right? So I showed you one DBT project.yaml file. So there'll be one configuration called profile name. So that profile name should be same as what the profile name that you give here. Only then it will be able to, because it obtains that profile name from there and searches for that in your local server or wherever you have deployed your DBT in any of these servers. So that's how, so from there only it will be able to get the connection details, makes the connection with DBT, and then it, runs the models. Okay. So this is DBT. Now, the another important configuration file is DBT project .yaml. So that is one main configuration file. It will have all the project level settings. What are the models that you're going to run? How do you want to execute that models? And then you could even set your variables there. So I had set that project name, data set name, right? So I showed you in the DBT project YAML. I have mentioned some variables there. Okay. So those variables only I used in that schema.yaml. So I could mention my global variables there and then use it in my models wherever I want. Okay. So this is one important key configuration file that every DBT project must have. Okay. So we are moving to next part now. So Jinja. So it's a templating language. So this is one unique thing. You're not a different thing which makes which extends the capabilities of a normal SQL statements. Okay, because this Jinga gets some dynamism into your SQL scripts. So what it allows is it allows to use your control structures, like you could use if else loops, if conditions, and then in your queries itself, as part of the queries itself. And then you can also access the environment variables. Now for example, you're writing a logs table, and in that logs table you want the airflow DAG ID to come as one of the field. You could access them directly from your models itself when it's deployed in airflow. So you could use this var function, var function, right? You could access that variables wherever it is deployed. You could access its environment variables. So that is one thing. And another is it can dynamically generate your SQLs. If you generate some template and then if you send inputs, then it could on runtime it can dynamically generate the SQL statements. You don't need to repeat that for all the fields. Okay, I think I have added a code snippet here. So there is something called payment method amount model. So on the top, using the Jinga templating, a payment methods are mentioned. Like it is a list of methods: bank transfer, credit card, and gift card. Right. So and then we have a select statement. Like for every payment method, there is some case statement there. And then so for every payment in that payment method in that list, right? When it generates that in the target folder, it would replace those variables. For every payment method, that case statement will be automatically generated. So you don't need to write n number of case statements based on your condition. If it's the same set of case statements, you could put them into if else, and then you could put them into loops and then generate the SQL statements in runtime. So this is one advantage. Which it makes a code looks quite simple actually. Whenever we use this reusable components, it'll look cleaner. And then, as I said, like if we mention the variables from in our DBT project.yaml, right? Those environment variables could be accessed in the models itself. So here they have used in the select statement. So this is regarding Jinga. And another is macros. Macros also, this is what enables modularity. Like in our application code, you would have functions, right? So why do we have functions? We have reusable components so that we don't need to repeat that logic everywhere. So likewise, now we have that power in SQL as well through DBT. So it gives this reusable parameterizable SQL scripts. It helps you to write more efficient and maintainable SQL code, and that could be also used across all the models. When I showed you PyCharm, right, I would have showed a macros folder. So under that macros folder, whatever you mention, it's again .SQL scripts only, but whatever code that you mentioned, that those are considered as macros, and that you could reuse across all the models how many ever times that we want, wherever that logic is reusable. So here I've again showed a code snippet. So under that macros folder, they have written a macro called cents to dollars. So that parameters that it accepts is a column name and the kind of decimal, how many decimal it has to consider. So what that gives is whatever the price that it gets, it divides by 100, and then for a particular decimal place, so that it converts into dollars. For example, this conversion now you are using in multiple models. Now here in the payments model, they have used that. So whatever that field value that comes from that app data dot payments source, right? So that will that field, like whatever the values that comes, it will go into that macro, will get converted into that dollars, and then that value will get put into your database. Right. So if you check on the target folder, this is how your so the final SQL will look like. So that macros will get reused here. So this is how that code gets generated now. So yeah, the last snippet is after the DBT compilation. So once when you run your DBT commands, that is how your code, the final SQL code will look like. So this is about macros. Okay, now we are going to go into another total different. Do we have any questions now? Okay, is it okay? Fine. Okay, but is it understandable, like to a certain extent? Okay, thanks. Okay, so now so far what we have looked at is tables, views, which are some traditional objects that are already available. As mentioned earlier, like incremental models are little different. 7 o'clock. Okay. So these incremental models are basically designed to only incrementally process your data. Like now, for example, you have a data set. This data gets refreshed on a day-to-day basis. You're getting like hundreds and millions of records. For example, yesterday I got some 100 records. The next day I'm getting another 100 records, and those records you will have to put it into a target table. So yesterday when the data is available, you get it into that data set. You load all the rows. The next day, you're again on another set of millions of records you're getting. You will have to get that also into your target table. So there are two options to do this. One is you reload this entire table where you fetch all the data which was the records which came yesterday and also the new records, but that would be first is time consuming because the number of records would become increased, and another it would use up a lot of resources. So this is one way. Another way that efficiently what we could do is somehow what is it, identify the delta records alone and then load that alone to the data set without fetching the records which were already loaded yesterday. So this is one thing. So this second part, which is more efficient to do, is to do that only incremental models are given by DBT. So it will only process that new and updated or changed records rather than fetching that entire data again. So this would reduce the cost and time in high scale. Now I'll show the one example, similar example, what I said. So we have an orders table. So we have two orders here, 1, 2, 3 and 2, 3, 4. So that until 2022, 131, those two records are only available. Now the next day or something, so on 2022-01, the source table has got updated with 3 records. Now we want this data also to come in. As I said, there are two ways. One is refresh this entire table that is like the select star from this entire table where we use the table materialization and then get all the entire data to this, or else identify this new record alone and then get one record alone to your target table. That would be more what is that, resource wise it will be less, right? So for that only we need incremental models. So for DBT to understand that incremental models, right, there are a few things that we'll have to mention. So one thing is, first you will have to mention DBT that you want to build that incrementally and not use the table and view kind of materialization. That is one thing. Another thing, you need some filter, right, to mention, to fetch only those updated records in that run and not the entire records. So you need some cutoff logic to mention. Another is a conditional block. Now, the first time when you load your data, you want to load that entire data what is available at the source, right? And only from the successive runs, you want that that logic where it filters only the updated rows. So you need to differentiate that. So you need some if block there, saying the first time get all the rows, from the next time filter the rows and then get that. So you need some conditional logic there. This is one thing. And the next thing is you need some unique key as well, right? Now when those new records comes in, DBT needs to know which record, if that record is already available, it will go and update. If that record is not available, it will go and insert a new record. For that, a unique key is also required, right? So these four things are required. We'll have to provide basically to the incremental models. So the first three I mentioned, right, the points that are required, we have something called is incremental macro. So I've mentioned what a macro is. It's again a set of SQL scripts where logic will be mentioned. So what is the result of that macro is, this is incremental macro is given by DBT itself. It's an inbuilt macro. So what it does is, if the table, that is this target table that where you're loading the records, if that table is already available, it will return true. If you're not passing full refresh flag, which means if you send full refresh flag, it won't do incrementally. It will truncate and load the data. So that flag should be false. If that is false, that macro will return true. And also, if the model is configured with the materialize as incremental, it shouldn't be materialized as table or view, because table or view does a truncate and load. So if all these are true, then our is incremental would return true, else it would return false. Okay, I'll now show how it is implemented. So now I have a config block. This is again a SQL script, a model SQL script. I have a materialized block where I have mentioned it as incremental. I have now mentioned by unique key as order ID, which means it searches for this unique key only to identify the records if they're already present or it has newly come. Now I'm selecting everything from orders, which is from my source. I'm selecting them, and then I have an if is incremental block. In under that if is incremental block only, I have mentioned that filter now. So we have something called updated at. So there is this column, right, updated at. So this update, so until yesterday, our data would have got updated with these two orders. So it is got updated until 2022 131. Now our new data has got data on 2022 21. So I have a cutoff logic to select records only the rows with updated at, which is more than what is maximum of available here, the latest what is available here. Okay. Sorry. So I have this logic. So what happens is, the first time when you run this target table, whatever table this model is going to create, right, that table won't be available in your database, correct? In that case, this if is incremental will return false, because that is incremental macro will check if that table is already there in your database. Only then this where filter will come into place. So the first time it will select everything. It will load all the records, whatever is there in your source. The next time when you, in the successive runs where you want to filter only the specific newly updated records, right? Those records are alone fetched, and then the usual merge strategy happens. Okay, there are some others. There are different strategies that are provided by incremental models, like merge strategy, insert and override strategy. By default, it is merge strategy. In your traditional SQL, what happens? Merge upsert. If there's a new record, it will insert. If there's a same record with updated values, it will overwrite. That is similar. The strategy is similar. Just that the merge strategy will have to implement it this way. So there is another strategy also called insert override. Uh, just Ram, do we have time, or how long can we do? We have time. Okay, thanks. Okay, so we have this insert override strategy, the another type of strategy. So as I said, for the merge strategy, what you saw is individually you're updating the rows. Whatever the records that are newly available, you're getting that records alone. There could be cases where you are kind of doing a sales reporting or weekly reporting, where you will have a weekly set of data. Right. So in that way, if your source is partitioned, like every week you get that data, and then that it is partitioned by the 5 minutes. Okay. Partitioned by week. So this insert override strategy, what it does is it it will replace that entire partition. For example, if your source for this week already the data is available, and in your target you are getting the same data for that week, it will fetch that partition, whatever is available, remove that data from that whatever falls into that partition, and load all the records, whichever is available from source. So for this sort of strategies are used where your source is already partitioned, and you need to replace that entire partition of records for reporting or anything. Because as and when your weekly data gets updated, you need that weekly partition also to get replaced with a new set of records and not have the old set. Only then the reporting will be correct. So that's this kind of strategy is used for that insert overwrite. So there are still other strategies that are available. I'm discovering these two. Okay, so we have multiple strategies. The main thing is how do we choose the right strategy? That is really important. So now even in the merge strategy, right? So in the merge strategy, what it does is, in this case where I have just mentioned the unique key, it will still have to scan the entire table to find where that unique key is present. Correct. In case if I have a partition on that updated at column, or if I had partition by that updated at column, when I have this filter, it will be easily able to find that partition. It doesn't need to scan that entire table. So when you will have to like have some configurations like partitioning and clustering are some basic things we'll have to implement when we use merge, so that collectively that operation becomes less cost. Okay, so yeah. So okay, one situation one is where you have you have a very large data set, extensive level of transformations are happening, and only there are some recent data changes. The historical data doesn't change, like a transactional data. Every day you get that data. The historical data is not going to change. Whatever the transactions that are happening, it is going to keep on update. So in that case, it's better to use incremental models. In another situation where the data set is small, but every day the entire data itself changes. We don't know, it keeps on changing. Then it's better you do a full refresh, because in that case, incremental strategy might not do its correct purpose. So it's okay to do full refresh, provided if the data set it has that type of data. In incremental itself, you also have that append strategy. If in a merge strategy, if I don't mention that unique key, right, it won't be able to identify the records. In that case, what it will happen? Well, if I don't mention the unique key, whatever the records are available in the source, it will append all the records, because it doesn't know whether that record is already available or not if I don't mention that unique key, which in turn does the append strategy. So if you're okay having duplicates for a specific unique key, you could go with append strategy. And other thing is, if your source is partitioned, it's better to use insert override. And if your source is not partitioned, you could use merge along with clustering the columns. That would suffice. And yeah, so this is one. Actually, there are more models, but it is time. So you could read about snapshot models. It's also that is also very useful. That is given by DBT whenever you want to track changes. So, for example, if there's order and that order goes through a series of shipping statuses. First, it's ordered, then it's shipped, then if it gets cancelled, all of that, right? So the source data would give only the latest, whatever at that point of time, what is this shipment status is what it is given. For example, if the business want to report for a particular product, how many days it is taking between each and every status, in that case, you will have to track that entire shipment statuses. In that case, you could use snapshot models. So I think you'll be able to refer them and understand about that model. Yeah, I think. Uh, I'm just wondering, without giving that conditional line, if it is incremental, still the result would be same, right? If I run the query, select stock models where updated at, still I will be getting the same result. But what is the purpose of again giving that incremental line? So see, if you don't have, okay, you mean where updated at is greater than. So, Correct, correct. Yeah, select updated as select maximum updated from this. Um, I always got confused. Once again. So what do you mean is if we see first time when you load the records, you won't have any data in your data set at all. Okay, then how would that maximum of updated from this, right? From this means that this is a Jinga templating. It means a target table. So that time it will give error because the table itself is not available now. So first time you want the entire rows to get loaded, right? If now if you're knowing the conventional merge query, right, you will have to write CTs, filter that, and then use this. In DBT, it's enough if we have this macro. If we use this macro, that is possible. Yeah. Okay. Um, I could take up some questions for 2 minutes. Okay, fine. See, ultimate purpose is one thing. If you write these SQL queries directly, you won't be able to dynamically do these many things. Okay, so for example, this has integration with GitHub and all. So you will able to track the transformation logic like you do in application logic. Your application code, you will be able to track them, all of them. So that is very important for collaboration and everything when you work with multiple teams. And another is this uh, transformation that you could integrate with any cloud. So it's not cloud specific. You would be easily able to migrate to any cloud platform. So actually, there are many features. There's a few of them. It still makes a difference. Yeah. Okay. Fine. Thank you. Thank you so much for listening for all this time.